The graph of the hyperbola is given. Match the graph to its equation below. So we have this picture of a hyperbola, and we want to match it to one of these equations. Before we do that, let's take a look at some of the features of a hyperbola. So first, we have two orientations that we're going to focus on, and I've written the two equations that match those two orientations. And those orientations are horizontal and vertical. Focusing in on the equation, the way that I can tell the difference between the horizontal orientation and the vertical orientation is by which term is positive. So in this first equation, the term that contains x is the positive term and y is the negative term. So with x being the positive term, we have a horizontal orientation. In the second equation, the y is the positive term, and that is with the vertical orientation. Then I've got a picture over here of our hyperbola, just to give you an idea of the features we want to pay attention to. All of the major features are going to fall along the transverse axis. This picture I'm showing you is of the vertical orientation, and this vertical line is the transverse axis. If we had a horizontal orientation, our transverse axis would be horizontal. So along that transverse axis, we have the center, we have vertices, and the vertex will be a distance away from the center, and you can see that A is in both of those equations under the positive term. And then we also have foci, and those foci will be C distance away, so C distance away from the center is the foci. There are also asymptotes, and the asymptotes pass through the center. And they'll show you where the hyperbola will be drawn. So along the ends here, the hyperbola will be getting closer and closer to those asymptotes. If I were to draw from the vertex over to the asymptote where they meet, that would be a value of b. And b is on this part of the equation here. So from the vertex to that asymptote is b. We can do it with the other vertex as well. So it kind of creates a little box here. If we focus on one of these triangles that show up in here, you can see that we have A, B, and C along those triangles. This makes a right angle. So we have a right triangle, and we can use Pythagorean theorem, and that's where these equations come into play. You can see that A squared plus B squared equals C squared. With all that in mind, let's take a look at this example. We have the graph of the hyperbola, and we want to match it to one of these equations. So I can see that this is a vertical orientation of the hyperbola. We have a vertical transverse axis, and I can see where my vertices are. I have a vertex at 0, 6 and 0, negative 6, and my center will be at 0, 0. So this tells me that A is equal to 6 because the distance between the center and the vertex is 6. So I'm looking for a vertically oriented equation where A is 6. So a vertically oriented equation will have the y being the positive term. So these two have y being the positive term. I can eliminate these two that are horizontally oriented. And because A is 6, this will be the right choice. Y squared over 36 minus x squared equals 1. Thank you for checking out my videos. Have a great day.